Okay, so in this video, we're going to be talking about the interior angles and exterior angles of polygons. By the end, I'm hoping that you'll be able to find the interior and exterior angle sums, as well as possibly find a missing angle within a polygon or on the exterior of a polygon using those interior and exterior angle sums. So first, let's talk about what a polygon is. Okay, a polygon is going to be a closed figure that has at least 3 sides, and they're only going to intersect at one endpoint. And there will be no adjacent sides that are collinear. So if you look at our pictures here to the right, this one you can see crosses and intersects, so that would not be considered a polygon. We've got rounded edges here for the second one, and for the third one there, it's not a closed figure. The first polygon here is considered a convex polygon, where all of the angles are on the inside and we don't have any protruding into the shape. And if we look at the next two, these are actually concaved polygons. So here, let me write those out for you. This one is convex, which is the ones that we will be working with, okay? And these two are concaved. And that's because they have angles that jut into the shape. So they're not really going to follow the properties that we're going to be talking about. Now, we do also have regular polygons. And this is when both the sides and the angles are equilateral and equal angular. So that means all the angles on the inside are going to be the same. Now, our interior angle sum is going to be 180 times the number of sides minus 2. So again, N stands for the number of sides, which is right down there. I'll scroll down a little bit. N stands for the number of sides the polygon has. We're multiplying by 180 because essentially it's how many triangles are making up that shape. Now, if we are looking for the individual angle on a regular polygon, it's going to be the total sum, which was 180 and minus 2, okay, divided by the number of sides. Now, again, this only works if it is a regular polygon. Okay, if it is not a regular polygon, that will not work. You have to add all of the angles up to the total sum and to find the missing one for ones that are not regular. So here we're asked, what is the interior angle sum for a 13-agon? Okay, so I'm just going to follow my formula. I'm going to take 180 and I'm going to multiply it by the number of sides, which is 13. Minus 2. And all you've got to do now is type this into Desmos. So let's take a look. All right, so we're going to type into Desmos 180, 13 minus 2, and we get 1,980. Okay, so we've got 5 angles of a hexagon. Remember, hexagon is actually 6 sides. 6 sides, for those of us that need to know that. Okay, we've got 122, 110, 95, 108, and 135. And we want to know what the 6th angle is. So the first thing we got to do is find out the total sum of our angles. All right, so we get that from taking 180 and multiplying it by n, which is 6, because a hexagon has 6 sides, minus 2. All right, so let's go to Desmos and type that in. I'm just going to change this to a 6 here. We get 720. And then we're going to set the sum equal to everything added together. So our sum is going to equal the angles we have plus the one we're missing, so plus x. All right, so we're going to have 720 equals 122 plus 110 plus 95 plus 108 plus 135. And lastly, plus x, and then we'll just go to Desmos and type that straight in. Okay, so as you can see here, I have typed everything into Desmos, and I just need to scroll out until I find my angle, 150 degrees. And again, these are angles, so we want to put it in degrees. All right, same thing here. We've got a quadrilateral, so we're going to follow the same thing. So quadrilateral has 4 sides, so I'm going to do 180. 4 minus 2 equals 82 plus 106 plus 88 plus x. And then I'll go to Desmos, and you can type it in just like this. You can type the 184 minus 2 in separately and find that value as well. Whatever works best for you. Okay, so here you can see I've typed it in, and then we just click our value there for us, and we get 84. Okay, so now we have talked about interior angles. Let's talk about exterior. They're actually much easier. Exterior angles is a total sum of 360, and it will always and forever be 360 for every single shape that is convex, okay? So if we want to find the individual angle for the exterior angles of a regular shape, we would just divide 360 by the number of sides. Again, in stands for the number of sides. So here we're just asked what is the exterior sum of a 73-gon? The answer is 360. What is the exterior sum for a 17-gon? Again, it will always be 360. Now here on this last one, we're actually looking to find the value of x and the value of y. So remember, the exterior sum is always 360. So we know all of these angles are going to add up to be 360. Now this one has got a little bit of a challenge to it, so we got to take our time. If we're looking at this shape, they gave us 2 angles already on the outside, 75 and 67. They also gave us that these 2 interior angles were congruent, which means that their exterior angles will also be congruent. So this will be y as well. Now we've got 2 values here though, so we can't say x plus y plus 75 plus 67 plus y is going to equal 360. But they did give us that this box here is 90 degrees, right? That's what the box is. And so these are actually forming a straight line. And a straight line is 180 degrees. So if we know this one is 90, it actually means that x is equal to 90 as well. So we've already found our x value. We just need to find y. So we're going to say 360 equals 90 plus y plus 75 plus 67 plus y. And now we've got all of our angles. Now instead of typing y into Desmos, I'm actually going to type x because it solves for x. And I could also have written this as 2y rather than writing it out as separate. It's whatever works best for you. So we're going to go to Desmos and we're going to see what it does. Okay, so as you can see, I replaced x in the equation instead of using y. And we find that y is going to be equal to 64. All right, now let's check out some challenge problems that go along with these. Actually, before we talk about those challenge problems, we are going to talk about regular figures, and then we'll get to the challenge problems. So For regular figures, these are the ones where the angles on the inside and on the outside are all going to be the same. So on the inside, they equal each other, and then on the outside, those angles will equal each other as well. So what is the measure of the interior angle of a regular hexagon? Again, a hexagon is a six-sided figure. All right, so I'm going to take 180 degrees, multiply it by the number of sides, which is 6 minus 2, and then I'm going to divide it by the number of sides. And again, Desmos will do this for me, so let's type it in. And we can see that when we type it into Desmos, we get 120 degrees, 120 degrees. All right, so let's go back. This is 120. And then it asks what the measure of the exterior angle is. And remember, exterior is always 360 degrees. And we're going to just divide it by the number of sides, which is 6. And so when we do that, we would get 60. You can type this into Desmos as well. All I did was 6 goes into 36 6 times, and then I added the 0 for 60. Now, if you notice, right, we've got 120 and we've got 60. So when we add those two together, we get 180 degrees. And this will always be the case. So for someone like me who struggles with memorizing formulas, I only choose to remember 360 divided by the number of sides for the exterior angle, and then I subtract from 180, because for me, that makes a lot more sense than trying to remember 180 n minus 2 divided by n. Now again, it's whatever works best for you. So let's try this again. We're asked for the interior angle of a regular nonagon, and nonagon is 9 sides. Now, instead of using my formula, I'm going to use the 360 minus and then subtract from 180. So I'm actually going to find the exterior angles first here. So I'm going to do 360 divided by 9. And again, you can type this right into Desmos. All right, we get 40. And now that I know what the exterior is, I can come up here and say 180 minus 40 is 140. And you would get the same answer that you would have gotten if you did 180 times 9 minus 2 over 9. All right, so now we're going to check out those challenge problems. Okay, so it's asking us what is the measure of an interior angle of ABC, a regular polygon shown. Okay, so they want the value of this angle here, and they told us it was a regular shape. So if we know it's a regular shape, we can just find the value by counting the number of sides and using our formula. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, so our formula says 180, number of sides minus 2, divided by the number of sides. All right, so let's go to Desmos and type that in. Oh, I put a +2. Let me fix that. Should be a minus. All right, so we get 144 degrees. Okay. All right, let's step it up. This time they're asking us what is the measure of CDQ? And we know that the figure hexagon here is a regular hexagon, which means the angles on the outside, which is where this is, right? It's on the outside of the shape, is going to be regular as well. So we can just do 360 divided by hexagon, so that's 6 sides, and we will get 60 degrees. Our last problem here is definitely the hardest one, so please make sure you re-watch this one a few times because I really want to make sure you get it. So they give us that two adjacent figures are regular hexagon and a regular octagon. Okay, so they're regular shapes. So we know we can use our regular shape formula. And we want to know the measure of PQR. Okay, so the first question I asked myself is, where is this angle located in relation to my shapes? And it is on the outside. So angles on the outside mean exterior angles. So I'm going to use 360 divided by the number of sides. Now, the first thing that most students want to do is add up all the sides. But that's actually not right. We want to split it into two angles and find each exterior angle and then add them together. So the top shape was a hexagon. So we're going to do 360 divided by 6, and we will get 60 degrees, which means this top one here is 60. And then we're going to find the bottom one, and this was a regular octagon, which is 8 sides. So 360 divided by 8 equals, all right, let's check that one out. 360 divided by 8 is 45. And now that we have them both, we just want to add them together, and we will get 105 degrees by adding them together. Here, I'll show that too. 60 plus 45. And 105 degrees would be the measure of angle PQR. If you have further questions, please make sure you ask in class.